All right, welcome back, trigonometers and pre-calculators, folks who need to know how to use and when to use the law of sines and law of cosines. So I'm giving you this little starting screen. I know it's very high tech. To point out that we don't just use them randomly. We pick the law of sines or the law of cosines based on what information we have to start with. If we have two angles and the side between them, specifically the included side, the one that goes between the two angles, or if we have two angles and not the side between them, so it really doesn't matter where the side is, we use law of sines. If we have two sides and we have an angle, one angle, but it's not the angle between them, if it is the angle between them, that's side angle side, we use law of cosines. But if it's not the angle between them, the included angle, that's a special case. That's a very special type of problem. It's called the ambiguous case because there's not just necessarily just one answer. There might be two answers. There might not be an answer. It's a whole nother thing to look into on a separate video. But the other case where we would use law of cosines is if we have nothing but sides. We know all three sides of a triangle and we're just trying to find the missing angles. So the big idea here for any of this is we're trying to find the missing sides and angles of a triangle, and it's not a right triangle. We did that in geometry where we found missing sides and angles of a right triangle. Now we're just trying to find missing sides and angles of a random triangle, not necessarily right. And that's called solving the triangle. So let's go ahead and do one. Here's the information I'm given on this particular triangle. I am told that little a is 6, little c is 9, and big B is 114 degrees. Okay? Now, one thing you have to remember is that on a triangle, we tend to give angles and the side across from them the same letter, where the vertex of the angle is a capital letter and the side across from it is the lowercase version of the same letter. Okay? So I'm just drawing a random triangle. I'm not trying to make this look like it's 114 degrees. I'm just drawing random, almost equilateral triangle, because all I'm really interested in here is getting an idea of their position in relation to each other, what side is across from what angles next to each other, etc. So C equals 9, and angle B is 114 degrees. All right, so I have two sides and one angle here. So that's two S's and one A. So theoretically, that could be either this or this. It depends on where the A is. If the A is between the two sides where they meet, which it is, here's a side, that's where they meet, then that's side angle side, so this is going to be law of cosines. Okay, so let's look at law of cosines. Law of cosines comes in three flavors, basically. It can look like this. It can look like this. And it can look like this. You use the one that is basically what you need. Okay, we don't use all of them at the same time. We don't all use all of them in the same problem necessarily. We use whatever we need. And in this particular case, I only know one angle, and I need to know what the side across from it is. I also need to know what angle A is and what angle C is. So I really have a choice here. I could choose to find the little b for side B. I could choose to find angle A or angle C. It's up to you. And what I'm going to do here is I'm going to go ahead and find little b. So if I need to find little b, boom, there's the one I need to use. And notice it's always the only angle. Each of these only has one angle in it. And the angle that's described is the one that's across from the side that's on the side by itself, the isolated variable. Okay, so b squared is by itself if you're dealing with angle b. C squared is by itself if you're dealing with angle C, and so on. Okay, so we're going to use this one right here. B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. All right, now when it's like this, when your variable is over here, really you could pretty much just type that right in your calculator if you want to. I like to simplify it a little bit first. Whoops, make that 36 plus 81. 20 12 times 9 is 108. Be very careful that you don't try to put these three numbers together, addition and subtraction, because the 108 is tied to cosine 114. This is all multiplication, and multiplication comes before addition or subtraction, so we can't separate that out until we're ready to divide it if we wanted to. We don't really want to in this particular problem. So I'm going to do 36. Let's get it up higher on the screen. 36 plus 81 minus 108 cosine 114. If you're using a graphing calculator, it's worth double checking that you're in degrees. You press mode and check right there, the third thing down, that I'm in degrees. And I am. And I get 160.927. So that's basically saying b squared is 160.93. And then just like any other time, if I want to get something alone and it's squared, I have to unsquare it, take the square root. Usually when you take the square root of both sides, you think about plus or minus. I don't need plus or minus because b represents a length. We don't have negative lengths. So now on my paper, I will usually write this, but I'm kind of a stickler for trying to keep it as accurate as possible. So since the number that I rounded to write this is already still in my calculator, I'm just going to go ahead and in my calculator take the square root. So I'm going to put second and then square root and then second. And if you hit the button for negative, it's A and S, it basically plugs in the answer that you just got above there. And so I'm taking the square root of 160.9275575, and I get 12.685, or about 12.69. Let's go ahead and round that to the nearest tenth. So there's my answer for my length of b. So now I have b. Now, when you are doing either law of cosines or law of sines, there very often comes a time when you could switch over from doing one to the other. The best plan generally is don't. If I have to start with law of cosines, stick with law of cosines. Basically, that helps you avoid getting into the ambiguous case, that weird case of the law of sines. But I was using law of cosines here. I'm still going to use law of cosines. I have found a side length that was missing. Now I need to find one of these two angles. Once I find one of these two angles, all I have to do is subtract to find the last one. But I still do need to use the law of cosines one more time to find a missing angle. So I need to find either angle A or angle C. If I want to find angle A, I'm going to use this version of law of cosines. If I want to find angle C, I want to use this version of law of cosines. I think I'll go for A. All right, so what I'm going to write, and I'm just going to go ahead and cover this up because I want to see that triangle. So angle A, I'm using the first variation. So a squared equals, I'm just going to write it out. And I'm putting that in parentheses. I don't know. You won't necessarily always see it in parentheses. It means the same thing if you don't. But the reason I'm putting it in parentheses is because otherwise you have a C and then a cosine. It's like CC. So we have 6 squared equals 12.7 squared plus 9 squared minus 2 times 12.7 times 9 times cosine A. Now again, if I can, I'm going to use what gave me the 12.7 instead of 12.7. And I'm going to go ahead and square that. It's still sitting there in my calculator. I might as well use it. So that was 160.927. So this is 36 equals 160.927 plus 81 minus, I don't want to write that yet. It's 2 times, and remember this was same 12.7 was this. So that's 12.685,72258. I really don't need to use that many decimals, but they're there, and it really doesn't take that much time to type them. And I get 228.34 times cosine A. Now, do not fall into a trap that happens to people sometimes here. They put this together with this, and then they want to put it together with this. But again, and I had a highlighter sitting here. I'm not sure what to do with it. This is like it's all one number. That's all being multiplied. So you can't add or subtract the 228.34 from something else without dragging cosine A along with it, and we don't know cosine A. So all I can do here is go ahead and put these two together. And that gives me 241.93. Then get rid of this. And now, sorry, I need to move it up. Now I can get the cosine of A alone because now I can divide this out. That's times. If you have a number written right next to cosine of A, that's times. So now I'm ready to divide it out, and that's the only way I can get that off of that side. And that gives me cosine of A is equal to whatever this fraction gives me. So let's see what that fraction gives me. So 205.93 divided by 228.34. Negative divided by negative is going to be a positive, so I just did positives. And that's 0.90185. So we're basically saying cosine of A equals that. And we want to know what angle would give me that cosine value. And so we do an inverse cosine. So A is going to be the inverse cosine of all of that. And it really doesn't matter how many decimal places I write here because I'm actually going to use this. It's already in my calculator. I'm going to do the inverse cosine, so second cosine, and then second answer puts that same answer back in, and I get 25.59, or we said for angles, let's go ahead and go to the whole degree. So 25.59, going to round to 26 degrees. All right, so back on my triangle, this is 26 degrees, which means now we have two angles. These two angles together add up to 140 degrees. So if I subtract from 180, I can find that C is 40 degrees without having to do any more calculations. Now, I want to show you something else on this particular video as well. And that is that there's something called Heron's Rule. And Heron's Rule is a way of, there's basically two ways of finding the area of a triangle other than what you already know, which is just your basic 1/2 base times height. There are two ways of finding it, or two formulas for finding it, that are based on triangles and what we know about their sides and angles. Okay, so in other words, you don't have to know the altitude, you just have to know the middle. So let's say I wanted the area of this particular triangle. So let's just go ahead and write the sides, because Heron's formula is basically just based on the sides. Okay, so Heron's formula starts out with finding a specific value. And this value is basically, it's a special number. And it's a special number that comes from taking all of the sides and adding them up and dividing by 2. In other words, basically, it's like half of the perimeter. Okay, so the perimeter, let's see, here, and we call that special number S. The perimeter would be 9 plus 6 plus 12.7, and we're going to divide that by 2. So let's do that. So 9 plus 6, 9 plus 6 plus 12.7, all divided by 2. S is 13.85. Okay? Now, the reason I need S is because the formula has S in it. The formula uses S. It uses basically two things. I guess it's really 4 things, but it uses the side lengths, and then it uses this special number S. Here's the formula. The area of this triangle comes from taking the square root of S times s minus one side times s minus the other side times s minus the last side, where A, B, and C are our three sides. So it really doesn't matter which one is which because we're going to do the same thing with all of them, and then we're multiplying everything. So for this particular triangle, S, remember, was 13.85. And then S minus A. Let's go ahead and call this A. 13.85 minus 9 is 4.85. Then let's call this B. 13.85 minus 6 is 7.85. And finally, this is C. 13.85 minus 12.7 is 1.15. I might be relying on mental math too much here. So if I get something wrong, always feel free to tell me in comments, and feel free to understand that if you're doing it right, you're doing it right. You might get a different number than me. Okay, so I'm multiplying 13.85 times 4.85 times 7.85 times 1.15. That's what I just did in my calculator, and I got 606.399. So 606.40, and I still have to take the square root of that, so I will, and I get 24.6. So the area of this triangle is 24.6 square units. I don't think the original problem told me what units I had, but whatever the units are of the sides, let's say they're centimeters. If they were centimeters, then this would be square centimeters. And that is finding the area of the triangle with Heron's formula. And it's something we usually look at when we're looking at law of cosines because we can do it with the same starting information. Thanks so much for coming. I hope that I was able to help you, and feel free to come back and visit on another video, and have a great time.